Assalamualaikum and greetings to all. Today's topic is on partial derivative, section 1, which is first order partial derivatives. Okay, the definition of partial derivative given here. The partial derivative fx of function fxy with respect to x is obtained by holding y constant and differentiating with respect to x. The partial derivative fy with respect to y is obtained by holding x constant and differentiating with respect to y. So here you can, in the definition, for partial f partial x, y does not change, meaning that we hold y as a constant. So here we have y and here we have y as well. For partial f partial y, we hold x as a constant. So you can see here we have x, here we have x doesn't change. The other notation that we use for partial derivative is this symbol, partial symbol. So mind you, this is partial and this is delta. So for partial derivative, we use this notation. So you can use subscript notation or partial notation. And if you want to find partial derivative at a particular point, let's say x naught, y naught, then we use this symbol or this notation. Okay. All right. Now let's look at examples. Okay. Before we go to the example, note here for partial f partial x, you differentiate with respect to x, but you hold y as constant. And for partial f partial y, you differentiate with respect to y, but in this case you hold x as constant. Okay, all right, let's look at the first example. First example, we have fxy is equal to 2x squared minus 3x squared y plus y squared minus x plus y plus 1. Okay, and we want to find the value of fx at 0.01 and also fy at 0.01. But before we can get the value of the partial derivative, we have to find the partial derivative first. Okay, so what you do is you differentiate a term at a time. So the first term, any point xy. Okay, first term is 2x squared. So differentiate that with respect to x. That will give you 2 times 2x, because 2 here is a constant. Differentiate x squared, we get 2x. The second term, we have negative 3. Differentiate x squared, we get 2x. And here y is considered as a constant, whole as a constant, just like the 3 here. The next term, we have y squared. Differentiate y squared with respect to x. That will give us a 0. The next term, we have negative x. Differentiate with respect to x, we get minus 1. The next term is y. Differentiate with respect to x. That will give us a 0 because we hold y as a constant. The next term is 1. 1 is a constant. Differentiate with respect to x. That will give us 0 as well. Simplify this, we get 4x minus 6xy minus 1. Then the value of the partial derivative at 0.01, we just replace x with 0 and y with 1, and here we get, this is negative 1. Okay, now for partial f partial y, we hold x as a constant. Sorry, for partial f partial y, differentiate with respect to y, but here we hold x as a constant. Oops, what happened there? Okay. All right, so again, we differentiate a term at a time. So the first term is 2x squared. Differentiate with respect to y, that will give us a 0. The second term, we have 3x squared y, so that will give us 3x squared. Differentiate y with respect to y, that will give us a 1. The next term, we have y squared. Differentiate with respect to y, we get 2y. The next term is negative x. Differentiate with respect to y, that will give us a 0 because we consider x as a constant. Differentiate the next term y, we get a 1. Differentiate the next term, a constant 1, that will give us a 0. Simplify this, we get negative 3x squared plus 2y plus 1. Okay, now we can find the value of this at 0.01. That will give us 3. So the answer for example 1 is 3. Okay, we'll continue with the next example in the next video. Thank you.